In this video, we have the indefinite integral, or trig integral, of secant squared of x over the product at tangent of x and tangent of x minus 1. And notice we got the secant squared of x in the numerator, multiplies the dx here, and we know that the derivative of tangent is secant squared. So we'll let u equal tangent of x. Then du will equal to secant squared of x dx. So now we'll put this integral together in terms of the variable u. So notice that secant squared of x dx over here, that's going to be your du. And any place we have a tangent, we're going to replace it by u. So we'll have a u here, a u here. So we have a du, tangent of x, that's going to be u. A tangent of x minus 1, so this will be u minus 1. So we have an integrand then that has a rational expression. That's going to be 1 over u multiplied by u minus 1. So you can use partial fractions on this one because you have distinct linear factors. There's not much algebra in this one, but you can also do it this way. The old little trick of adding 0. U minus u is 0 plus 1, so haven't changed it yet. So I'm going to do this then. I'm going to break this up. Say this will be u over u times u minus 1. We got these two together then. I'm going to factor out a minus out of that. So these are the same thing. Same denominator here, u times u minus 1. U minus u cancels out, and then a minus 1 is plus 1, so it's the same thing. Notice that for this one here, the u and the u would cancel, and that gives me 1 over u minus 1. And then this one over here, the u minus 1, the u minus 1 will cancel, and I get a minus 1 over u. So we can write this integral then as 1 over u minus 1 and minus 1 over u. Now you can use the partial fraction technique. Select your constants a and b, and it works out the same way. So now we have it set up here. So notice we have a constant in the numerators here, and the denominator is a linear expression polynomial, degree 1, u minus 1 and u. And the derivative of each of these is 1. Derivative of u minus 1 with respect to u is 1. Derivative of u with respect to u is 1. So that means that we can easily integrate this using the natural log function. So this, for the first one, this will just be ln of absolute u minus 1. And got a minus, again, natural log of absolute u plus the constant of integration. This been the other way around. This had been a 1 minus u. 1 minus u. Then the derivative of that would be a negative 1, so you have to make up for that, so you have to put a negative here. But as long as the derivative of these denominators is 1, and you only have constants in the top, you don't have a variable up here, then it's always going to be the integration will involve the natural log of the absolute value of whatever you have in the denominator. Now you're just going to go back to the original variable here. So this will be ln. U is tangent of x. Replace the u by tangent of x. So we have natural log of absolute tangent of x minus 1. And it's minus natural log of, which is tangent of x, plus the constant of integration. Now this is really your solution right here. That's the answer to this particular problem. Now sometimes you'll be working problems and the instructor might want you to simplify it, write it in terms of something else. So you're going to do a little bit more. Or maybe you're checking yourself and you're working problems from the textbook that have the answers and you work it out and you think you got it correctly, and then you look at the answer in the back or from an online site and it doesn't match your answer. All you got to do is just simplify it further. So this is pretty much the end of the video. So you can do your thing if you want. I'm going to continue just for a little more in case for those people that want a little bit more to look at. So again, this is it. But I'm going to take it a step further for those that are interested. So for this one here, and I'm going to abbreviate this. So I have trouble with this little pen here. Can't keep it straight as it is. I have bad handwriting, and it's right with these little screen pins. It's really difficult. So this is sine over cosine here for this one. Same thing for this one. So I can write this as sine minus cosine over cosine. All right, sine over cosine, and then combine them together. So this is in the log here, absolute sine minus cosine. And then you can break it up using properties of logs. When you have a fraction, you can write it as the natural log of the numerator. So this would be natural log of sine of x minus cosine of x, and then divided by cosine, so this would be minus natural log of absolute cosine of x. So we get that. This would break up. This part of the problem would break up into this here. And then for the next one, forget about the constant for right now. I've got a minus then. I've got a minus here. And then this is natural log. Let me write this a little bit better here. So this is sine over cosine. So again, I have the natural log of a fraction. I can break that down into natural log of the numerator. That would be sine of x. That's just a fraction, then it's going to be minus the natural log of the denominator, which is cosine of x. So this minus then multiplies this one here, so this becomes a negative here. This becomes a plus right there. So I get minus log, natural log of cosine of x, and a plus over here. So these cancel out. These cancel out. So I have that left is this and this one here. So this answer here that I just gave on the right side here can be simplified into this. So it's a natural log of the absolute value of sine of x minus cosine of x minus the natural log of sine of x, and of course you have your constant of integration. Thanks for watching. We'll see you next time.